All right, the next presentation is going to be given by our wonderful engineers at Holisticon, who's one of our partners. We have with us today Simon Zambrovski and Jan Galinski from my very favorite German city of Hamburg. So with no further ado, please help me welcome them.
Thank you. Hello, guys. Thank you for attending. It was very delicious outside, so let's try to compensate it with our brain power again. Okay, so thank you, Sarah, for introduction. My name is Simon. This is Jan, my colleague and friend. We are both consultants at Holisticon. We are both backend developers, software architects, and we did a lot of stuff previously with other technologies, especially we are both passionate business process automators using process engines and so on. But today we have a different topic here. So we're speaking about domain-driven design, CQRS, Axon Framework, of course, and we love to do it in Spring environment. We are Kotlin lovers, so let's maybe get started with that. So the question was, what is Holisticon? IT consulting, we have actually captured the northern part of Germany. We're a cool crew, we're about 90 people, and yeah, all the other facts are not so important. We do a lot of different stuff, not only software engineering. We also do some smart data, some security, UX, UI, and we, of course, do agile transformations and organizational stuff. And business process automation, of course, so if you like this. And of course, we're hiring, so if you are in the northern of Germany, speak with us. So why we are here today? We both love architecture. And we discovered domain-driven design. Actually, I mean, I was trying to read the book like a decade ago, didn't understand that. Then I discovered Axon Framework, and then said, now it begins to make sense again. So I came back and tried to get to read it again, didn't understand that, and yeah, you know the story, right? But we are in a domain where we're working for large corporate customers, and they are usually building large-scale applications. So we have to deal with all this complexity and all this stuff. I think it was in conference like 3 years ago here, as one of the, I'm not sure it was alert or not, there was like, you won't get any smarter after this talk, but you can ask smarter questions. And I think this is a very good thing about this conference, that we get a little bit smarter by getting these smarter questions. Yeah, so let's begin. We need a little bit foundation, and I mean, most of you have heard these words and acronyms. We put it in a certain context, so sorry for maybe some repetitions. Okay, so DDD, who have actually really read this book?
Wow.
Wow, a third. A third of the audience. This is wonderful. Usually it's like 2 hands. Yeah, so domain-driven design is a set of principles for system implementation, right? And it covers not only the stuff that software engineering is doing, or where it actually starts, but it starts way before, right? Requirements engineering is a key feature in all this domain-driven stuff. And in this requirement engineering, we've seen already some talks about how to model your domain, how to separate this domain in subdomains, understanding the domains, identification of something like bounded context, which is exactly this transition from requirement to solution. So saying, OK, I have something like identified some similarities, so there is some boundary, and there is a semantic boundary for meaning of words. So if we're speaking inside of the bounded context, a word has a precise definition and one meaning, right? And especially there is this next step, which is called context mapping, and this is when we have several bounded context, and they relate somehow to each other. And there we can, for example, find out that the same word appears in different contexts, and they have slightly different meanings, and this is OK, right? So this is our way of tackling complexity. And then there is a lot of stuff about the tactical design, actually, and a lot of design patterns, how to use all this stuff and how to construct systems. So we've selected a few patterns from this whole blue book because we think they are pretty important if you not only building like a monolithic application, but if you are in context of these microservices. So on the modeling side, you have this context mapping where, I mean, this is a diagram and a notation coming from the books that every context is like a boundary, and then you draw a line between them, and then you try to identify how they are related and how they work together. And the easiest way not to work together is called separate ways, right? So they are kind of completely independent. That's easy. But the life is not so easy, so sometimes they do work together. And there are some more patterns not named here, like shared kernel and so on. In context of microservices, you don't want to share stuff. So we concentrate on this upstream-downstream dependency. What does it mean? In an upstream context, I can succeed without the other. As a downstream, my success is somehow dependent on that context. And we can also notate this with small u and d in the diagram. And usually, this also means that this dependency between the contexts will result in a dependency in a software. So it's pretty important to look at this particular thing, especially because if we are contacting, as a downstream service, contacting the upstream service, we have to communicate with these concepts that are used there. And the question is how we know what is meant by the customer there, right? And so there is one pattern, or basically it's a combination, open host service and the published language, saying, OK, I expose part of my semantical meaning to the outside. And as a downstream, I can use this meaning by actually taking these words and saying, OK, I use it exactly with the same semantics. But if in my downstream context the term is also used, I will do something like an anti-corruption layer, saying, OK, your notion of customer and my notion of customer, of course, it's the same customer, but I have some other details which are not relevant in your domain or in your context, and another way around, right? So this is this kind of transformation taking place. And the important part is that this transformation is not happening in software. It's happening actually in the domain, right? So if accounting guy is speaking with the customer relationship guy, and they speak about the customer, they mean different things, OK? And different attributes. And yeah, so this is about this modeling stuff, right? And then we have this tactical design. Tactical design is what software engineers are doing. So a lot of patterns like value objects, entity aggregate, aggregate root, and there is more, domain service, factory, all this stuff. We know all this, right? Usually, we start actually with domain-driven design exactly at this point. We say, hey, wonderful. Spring is somehow implementing part of them, and where this comes from? It's from Evans. I think it's too late. We should start there on the top. So CQRS ES, wonderful acronym. The first block is standing for Command Responsibility Segregation, Command Query Responsibility Segregation, yeah. So it's a pattern introduced by Greg Young, and it's very important to understand why he did this. So what the hell, why he said, let's separate this part. We're speaking about a single domain, and currently we say, OK, write operations, read operations. And the main reason is not because it's easier to build append-only event store. The main reason is because we want to reduce complexity of the main model. And by putting everything in the same shared database, we run in danger to say, OK, we are doing this compromise thing with the, let's put these attributes also there, and then put a little bit more attributes there. And finally, you end up with joins over 25 tables, and it's not performing anymore, right? The point is, this is a trick not coming from nature. In nature, we don't have a separation of commands and queries, right? But it's a trick that we apply as humans. So the idea is if you apply this trick, then you can actually handle these two parts of the problem independently, and this gives you the ability then to scale out independently. And this is especially interesting if, for example, your command and query side are completely different. Like you are only sometimes changing something, and the whole internet is reading your stuff, right? Then you need different load, different non-functional requirements there. Event sourcing. We had a talk on that, right? So should be easy. We store events instead of state, and we can derive the state later on from the stream. So a persistent strategy. And putting it together, there must be a way to communicate the change from the command to the query side, and we use domain event, and we use the same domain events for the storage, right? So kind of fitting together. So let's go further. In the context of microservices, we've seen different architecture styles over these 2 days now here. And there is a particular one which is called Onion and sometimes called port and adapters, which is about that you have a kind of, like an onion, having these rings. In the center of your ring, the domain model lives, and this is your pure business logic. And you can have long discussions how pure it should be. And then there are rings outside, and then there are two parts, actually. So all the input coming in is coming using the primary or driving adapters, and they're using some ports to access, actually, your application. And everything coming out is secondary or driven adapters. So it's kind of a port to something that is outside of your system. So why is a good model? It's a good model because this model introduces some constraints. It says, actually, you should never have a dependency from inside to outside. It should be another way around. So it's OK to access from the driving adapter, the port, the infrastructure ring, the application, and the domain ring. But domain should not actually rely on any application stuff, and of course, not on infrastructure stuff. And this is very important, because then technology can change. We can change the infrastructure without changing our domain logic. So this is a very basic principle, but it applies actually very good if you're building independent components. And yeah, that means that, of course, you need something like dependency injection or inversion of control, especially to be able to implement something like this, right? Now, the next building block is Axon. So funny to have this slide here, but still, most of the facts are kind of clear. I think the most important thing here is that we have these 3 buses. So this is the main abstraction that is introduced by the framework, and this is the way of thinking how you model your world, actually, in the end. And it gives us I wouldn't say one of the best, I would say the best CQRS ES implementation ever. And it also has some additional properties. For example, this kind of separation of business logic from configuration. So you can start actually with one configuration, and you can implement the entire business logic, and later on you can change configuration without touching the business logic, which somehow fits in this onion style, right? So it's a kind of infrastructure thing outside, right? Yeah, this is a funny slide from the documentation. Most of you have seen it probably, so let's skip that. But this one is what we actually observed. So there is an idea of a system evolution built with Axon Framework. And I couldn't find the slides, actually, that Allard used a lot, how to go through the desert, right? But so the idea is build your components using this abstraction of communication buses, build them independently, start as a monolith, don't deploy Kubernetes on day one, okay? Then you can distribute along buses as if you think there is a need for this, so there is some demand to scale out, and then you can actually scale out stuff, especially projections are usually scaled out. Then you have this nice ability, because of event sourcing, that you can build new projection later, and you have all the events from day one, because they're in the event store, And then you can even change infrastructure and do all this stuff. This is all valid and wonderful for a single context, right? So we are speaking about one bounded context with one domain problem solved in it. So let's put a little bit on the slide together. So we have these onions architecture principle in Axon Framework. So it's not usually it's like a circle, but I like this hexagon much nicer. They look much cooler. So we have the domain core, right? And because we're using CQRS, we have a command model there. In this command model, we receive command using a command bus, right? And we have a query model there. So we will receive something from the query bus, right? Kind of logic. And of course, the buses are the infrastructure, and it's not part of our domain core. So now imagine there is some client wanting to send commands or send queries. So we start using something like a command gateway, send a command. This will load. It doesn't matter, is it event source or not event source? But of course, we assume in this case it is event source. So using an aggregate factory, the aggregate gets loaded, which is part of the command model. It will interpret this command, and it will send out an event, right? Using an event bus. This event, in this case, is the domain event that we are using for the event sourcing, right? So this is exactly the event sourcing stuff. I just skipped this part because people are sometimes confused about this meaning of the event. So this is the inside persistence event of our system, right? And of course, we have a magic infrastructure called event bus. So this domain event is delivered to our projection in our own context. And then we can store the read side, okay? And maybe also some repository outside. Just wait, I will pull it all, and then you can make a picture. It will follow a little bit. So now if we want to query this query model, we have separation maybe also in the REST adapter, maybe not, but we use this query gateway to ask the question. It will be delivered to our query model, and the query model will load the data, and then we are fine, right? So for single context, we are kind of done. Actually, it could be something else. If this particular event or another event that is that relevant for the outside world needs to be published, there will be another types of event published to outside. This is not the event we are using for event sourcing, but it's just something relevant for the entire business, maybe in another domain, has happened, okay? So we call them pivotal events. There are different names like milestone events or pivotal or egress event, as I learned on this conference. So we call them pivotal. And of course, there can be pivotal events coming from outside that influence our query model, for example. And there are more event handling components. A Saga is, for example, one to run kind of a workflow, so reacting on event and maybe sending commands. And of course, it's interesting in all kinds of events coming in. And the Saga might actually call the command bus internal one or an external one, and it can also do some queries and whatever, right? So now we are like, now you could make a picture. I think this one is complete now. So this is just nothing invented here, right? We're just trying to apply what is there and how we can actually visualize what is being built there for a single context. You think I'm crazy, right? Maybe you're right.
I think you are, yeah. Yeah, this can give you headaches. I've been there before, maybe still am. We learned today about the importance of storytelling, so I start off with a story. A couple of years ago, Simon and I, no, I said Simon to you, we had discovered Axon Framework, and we had this feeling that we are now beyond this hello world, gift card example, banking example stuff, so we felt really clever. We went to the Holisticon. We came back and felt really stupid again. We took an advanced class with Steven. I can really recommend you to do so. And then we felt like, okay, we are engineers, it's not just learning, we have to build it, we have to break it, we have to fail, we have to explore, because we believe this will be the next big thing in our professional lives, coming from process automation before. Luckily for us, we have a company, Holisticon, where we get the Fridays off, so to say, to follow up on those hints and do some research and building some internal projects. And we did that. We sat together for a couple of days. Of course, I was the one trying to just get to the code. Simon pulled me back to the whiteboard, and we built a system. Compared to the other things we saw these days, quite silly one. We're building a system where you can track your table soccer events when you play in your company. Will get out somehow, so it's not really a silly thing. And I remember this day where we had this first thing, so you could somehow score a goal, and then there was some domain core calculation, and then we could query the current result, and if the set is won and everything. And I was exhausted, and someone was smiling. And I said, "Why are you smiling?" And he said, "Well, you might have not noticed this, but we reached maximum complexity. So this is not trivial, but if you manage to work with this, you can build anything. The world outside is chaos. Your domain is at least complicated, maybe complex. Your solution cannot be trivial, but this is it. Let's just keep it, because this is a good story." We were young and naive. Context management, cluster setup, versioning, evolution, compensation. Of course, this is not it. But was for me, that was the day where we said, okay, now we can really start working. And since then, we did a couple of customer projects, larger and smaller ones. And this is what we want to talk about today. The single context internal stuff, we just fade out. We are now focusing on what happens if one context using Axon technology principles talks to another context. So we have this first reduction, and because it's shortly after lunch, we shrink it down to this building block. So when we continue now, we're talking about a context. We do not talk about how many services are in this context, or how the persistence inside this context is done, how many query models and sagas you have. This is just, there is some logic inside, and we communicate outside using defined buses for command, query, and event. In principle, this is also Axon agnostic, because you just need those buses. But as we heard at this conference again, other message broker infrastructures don't really take into account that the command, an event, and the query are just different kind of messages. So it's an Axonic conference, so just imagine we're using an Axon server for inter-context communication from now on. And of course, communication means we have at least two of them. And because we like stories so much, we started doing this. And every time we have two contexts that somehow need to collaborate, we found that we did different approaches. So on a Friday lunch meeting or at the table soccer table, we started discussing, we had this problem to solve, we did it this way. We said, we did it slightly similar, maybe that's a good idea. Didn't work for us. Why? So we started to discover and observe patterns. This is really important. We do not invent patterns. We observe patterns. And what we are doing right now, and this takes us starting a discussion about how we communicate. So it's language. We observe patterns from our projects, we discuss them with colleagues, and we give them names, and we tell you about it. We do not claim that we invented anything. If you say, I know this, yeah? Don't leave in anger and say those two consultants from Hamburg claim to have invented gravity. It's a good sign. If you know a pattern I present you now, it really is a pattern. It helps us a lot to continue formalizing this. And our goal is to have a small set of patterns and then not only describe them, but find criteria when should I choose which of those patterns. Unfortunately, we do not live in a perfect world, so the programming, the technology behind this is simple. I think Florian, you mentioned it earlier. Of course, all these patterns Conway's law apply because we have teams and organizations. And if I can apply a pattern which seems like a cool solution for my problem, also depends on how my team is organized. The good thing, when I start now with the patterns, we already have the first pattern, pattern 0. You know this is, Simon told you about it, separate ways. Perfect. We have 2 contexts. They're just on the slide, and we do not have to care about them. Thank you. No. Of course, we want to talk about interesting patterns, or at least what we think are interesting patterns. What happens if at least 2 of those somehow collaborate? Because we have CQRS, we also divided them in command side and query side. And luckily for us, we found 3 for both of them, which is always perfect. If you talk about patterns, you're unlucky if you find 4 or 13. So 3 on each side is perfect for a talk. Let's start with the first one. So we called this, yeah, we need a language. We need to define some words. We called this master data query. Or in short, you know something that I want to know, so I ask you. Importance here, like Simon mentioned, we have this U and D declaration. So on the, how does this work? Fancy stuff.
There is a U. Yeah.
Wow. On the upstream side, I have a component that can do its purpose, just continue working without knowing the downstream side. But on the downstream side, we need some data from the upstream side. What do? We send a query. We get a response. We are done. That's what I like about this pattern. It's really simple. It's a good pattern to start with. Of course, simplicity often comes at a cost. So what we discuss a lot is we have this runtime dependency. So I can only use this pattern if the system I'm asking is up when I'm asking. Otherwise, I get a failure. When we discuss this, the first response, of course, is we are not Netflix. So I think you can reduce the challenge or the risk of this dependency just by claiming that if your team builds context and services and they run in the same OpenShift or Azure cloud, one of them goes down, probably you're not able to do anything. But this is definitely something to consider. On the plus side, it's as easy as writing a REST GET. On the downside, all the downsides of a REST GET. So when you ask for customer data, for example, because you need some information to send out a letter at 8 o'clock, can you still use this data at 9 o'clock? So there's caching involved. But with this example of customer data, what we really like to use it for, we have no data redundancy. So all the data stays in this one context and system. And if we need some of it, we ask for it. And we do not have to deal with managing personal data, sensitive information on our side of the system. OK, fine. Master data query. Let's go on to another query model. We saw that maybe it's not a good idea that if we do not know that stuff changed. And so the next one is trigger a query. Again, we are the system on the downstream side. We want information. But this time, the upstream side is kind enough to tell us that something changed. So we get an event, some kind of notification or trigger event. After the C up there, so the state changed, I get an event. And I go there and say, OK, obviously something changed. Please tell me more about it. This notification event might be as simple as order status of order 17 changed. So this is just, we shout it out on the floor, and everyone who's interested will try and come to find more information about this order 17 everyone is talking about. When we look at challenges of this, of course, there's still runtime dependency. I mean, we have this event, so this is decoupled. We could then later query, but at the moment we need the data, we will still have to query a running system. And we can use this for cache invalidation. We promised a bit of practical experience. I called this a query avalanche. So one small impact and the whole village is covered in snow. We built a system once where we agreed that we use this pattern, just send a notification event, small trigger, and then we ask you. And then the system on the upstream side, who didn't care what we are doing, did a nightly batch job, updating millions of data entries. So the system was under high load. Each of these changes triggered a notification event to our system, and our system said, cool, there's something new. I ask you now. So a system that was under heavy load got 1 million of query requests from a system that so far wasn't under load, but now, of course, was, and they both just escalated. It took some hours, and Simon said I was lucky that it only took some hours until things calmed down again. But this is something you should consider. An idea may be, because we talked about caching, you just use this for the cache invalidation, but not for the actual data loading at this moment. So the next time you really need to access the data, your cache is invalid, and you do the request. OK, last, and this is maybe the most typical pattern when we think of event-driven. We call it the query irrigator. This is, we get data from the upstream, and we just consume this data, this event, and build our own projection from it. So again, we have a state change up here. We get an event, and we update our query model. This is perfect in the sense that we are completely decoupled. We can consume this event anytime and build a custom projection that we are really interested in. Problem is, this is an event now that's not just anymore, here's an order change for order 17. This is an event now that needs to transport data that I need in my projection. So some call it a fat event at this place. And since my team might be interested in a certain set of data, and another team might be interested in other data or more fields in this event, when you implement this, you are the team implementing this on the left side or upstream side, you might ending up changing your event API just to do other teams a favor and include small extra bit of information, or you start sending out not one but 17 specific of those, and all of them are just picking what they need. So kind of was the same with the query already, but if you define these kind of events, you really have to be careful, because these are not your inner domain events. This is not a customer married and changed his name, or customer moved and we have a new address. This is, I don't know, the current address, like a snapshot event where you transport the data, or some state changes.
Just a second. Yeah. An interesting thing about this is that you're actually emitting an event from the upstream side, so you actually don't care, right? In the same time, the semantic of your event is so important for the others. So it sounds a little bit like a challenge how to do this, right? So how can I deduce those important events, then later on, sending them out will fulfill some properties for all the other consumers who are interested in this. Go on.
Yep, thanks. Yeah, we should mention we observed patterns, we gave them name, we made them somehow closed or disjunct, so we can say this is this pattern, this is this pattern. A combination of both works. I mean, in this notification event, you could set a common set of data that most of your potential query those who are interested in this data agree, and then you could say, if you need more or special information, now you can send a query and ask me back. So this would be a compromise using both patterns as well. I think this concludes already the query side. So let's go to the command side. We again start with the most simple one, reacting to fact. Again, this is when you're not using Axon, you're just using this event-driven or message-driven. I've changed some things on my side, and I inform you that I did it. Last week I had a nice example. Someone just holding the presentation, he put a bottle on the desk. And said, this is a bottle-placed event. We cannot say, no, you didn't. Or, of course, we can argue, please remove it again, but this is a fact. So a fact happened, and your system has to deal with it. This is the upstream-downstream relation. They didn't care about us. So they did a state change internally. They inform us. And this time, it's not only important for our query model. This time, it will affect our internal state. Maybe, I don't know, via the system responsible for calculating credit offers, and we get informed about some regulations or interest rate changes, and we have to use this because we need it in our command model to validate if the next command will be a success or failure. Again, benefits. Simple, you just build it. You're completely decoupled, so you do not have to be to care if you're up while this event happens. You just, when you wake up, you consume it and you see the change. Problem, you have no way of somehow saying that you are not able to work with this fact. What happens if it doesn't fit in your model? So you're directly dependent, and you just have to accept this somehow. From a developer point of view, if you're building this, we had this Saga inside here. So we are receiving an event. We are using this event to build a command, and then we are storing an event again in our internal system. Then we are using this pattern, and I work with colleagues who have not gotten just used to this. I mean, this is terrible to do, but you get used to it. It's hard to explain why we should do this, but this is exactly this ACL stuff Simon was talking about. So we cannot just take events from another system and put them in our state. We have to run through this, but a bit tedious to do. This is called choreography. That's important, maybe. Good that I took some notes. Next thing, when we say, okay, we know that we want something done by an external system, but we also know that this might fail. We can use a Saga pattern with this upstream, downstream. We have a downstream Saga. So we have a system somewhere upstream, which is working perfectly fine, and we want it to include in our process. So it's sub-functionality or sub-process we need to be done. But we cannot be sure that it just will react to some fact, or if we command it to do something. So the pattern here is we have to ask. So we have to be polite and say, please, could you? So we have a change now at our side with this asterisk there. Thank you. That is just temporarily. We do not know if this will be successful. We send a command to the upstream side using Axon Server. If it's really simple, it's a synchronous thing, and the upstream system now knows this will fail. I cannot do this. I would get an exception on the command, and I could say, okay, this didn't work. If it's a longer running, maybe asynchronous process, whatever, behind this, and I stay in this in-between mode on my side until the system upstream confirms the state change and notifies me with an event, which I handle then. Events are received by Sagas, not aggregates, and I change my state model. This is pretty useful. We do it quite often because you have a decoupling, and you do not rely on systems just doing what you want them to do, but you have this, please remove this bottle again, it cannot be left there, and then you know, okay, I have to do something else.
So you have kind of double confirmation. So your command was valid, it was accepted, first confirmation, and then sometimes later you get the event containing, especially if you're interested in the result, like a calculation result, of course you have to wait for this event because this can take some time, but at least it's like double checked, right? So received, yes, and calculated, yes. Then we can continue.
Yeah, you can imagine, so let's focus on this one. If you're doing this with a couple of systems, so you have a process you want, so purpose of your context is to provide some process outcome. You need several of those to work for you in a sub-process. You have an asterisk state in between, a double asterisk, so you are waiting on many combinations. What happens if this fails, but the other one says yes, so you become not a choreographer, but an orchestrator for some kind of sub-process or sub-activities. And when you notice that you are doing this, might be a good idea to accept this. There's a long ongoing discussions between the process automators like we are and the event-driven community. Do we need some external component orchestrating how processes flow?
So it's a religious discussion, orchestration.
No, it's not a religious discussion, we are right.
Yeah, okay, yeah, that's why it's a religious discussion, yeah. So do you need orchestration, do you need choreography, and to what degree you need what of them, right? But so, this is the pattern about the orchestration.
Yeah. Yeah. So the important thing is that the both services, typical example, book a flight and you want a hotel in the same city at the same night. If one of them fails, they both don't care about. So Lufthansa wouldn't just say, I check if your room is available before I book your flight. Typical example for distributed transactions. So the man in the middle there says, if you can handle it, I take over. Core element here is the Saga in between. So the Saga is exactly the building block to deal with both of them possibly failing. What happens is I send a command to the first intermediate state again, confirmation, let's stay with the happy path. I send a command to the second one, intermediate state, confirmation, and then I send the acknowledge commands, so I have final state on both sides. From all the patterns we've seen, this is maybe the most complex because it really involves a third party, but it's really useful, and it was funny yesterday and today, some people spoke to me about Camunda. So the Saga in this case, the concept is still the Saga, but this can be a business process. So we do this regularly. If we have complex orchestrations, we do not rely on some start Saga annotations on some 300 lines methods. We have a BPMN process running on a process engine to do this. And of course, the world is still chaotic, our domain is complex, but here we can really do compensation in a controlled fashion. That were 3 query and 3 command patterns. Do you want to sum it up?
Let me sum up. So, as we started from the beginning, I told you that developers are very interested in this tactical design, but don't care about the strategic stuff, right? So this kind of requirement engineering, this is done from other forks, and yeah. But as we've seen, this context mapping and this small U and D there in the diagram, that looks so silly, like, 2 letters. But this influences a lot what kind of communication you should consider, right? Because it's all the time U and a D on the other side, and you can compare this, and it's always information flowing from one to another, but you can do it with a query, you can do it with a command, you can do it with an event, with some restrictions. So again, it's not a solution. We don't have these requirements now, like principles when to use what, but we will actually continue to collaborate on this, and we invite you to join us in this.
There were these orange dices. They are really useful if you need to find out if it's command, a query, or an event.
You do it like this.
Try to get one. It makes this much simpler.
Yeah. So do these proper context mapping, and these relationships does matter for your design. And actually, what we observed, that sometimes you're like in a situation that you say, okay, we need to connect to this other context guy, and you're driving this on this is a technical discussion, which is completely wrong. This is not a technical discussion. If I call you or you call me, is a domain problem, not a technical discussion. Okay, so go to your domain and search for the answer there. Yeah, CQRS. I probably don't need to tell you about this. This events-only approach doesn't work, right? So you need the other messages, of course. And of course, use Axon Framework if you do it on JVM. There are no other options. It's the best thing you can do. Practical, even in a multi-context world, start with a monolith. It doesn't matter, actually, because as we've seen, if you follow this abstraction for one bounded context, you can also do it with multiple. And this deployment area and this location transparency that is given to you by the Axon Framework and Axon Server gives you the possibility to decide this deployment stuff on a completely different level than the business side. So do that, and only distribute on demand, because then you're doing all this technical plumbing instead of asking and looking for problems in the domain space.
I think that's it. Maybe just in time. Thank you.
Thank you, thank you.
Thank you so much, guys. Actually, there was a question asking for the links to the repos. So no, not here. So if you don't mind sharing that on the app, that would help. I'm not sure which repo they were referring to.
We do not have a repo here, so maybe this is for the testing yesterday.
Yeah, probably that.
Yeah.
OK, great. I think we have time for one question. Anyone?
Looks the same result as last time. We have one.
Everybody's waiting for another person to break the ice. All right.
As I asked also in the app, with the trigger query pattern, I've considered something like that myself, but I was wondering if you don't have a consistency problem, because once the event triggers the trigger, then how do you know that if you fire the query, you will get a response that already includes that what caused that trigger?
Yep. This is a very good question. It reminds me that I had this in my notes and forgot to talk about it. Of course, well spotted. If I have several changes within this short period of time, the first one might query me, trigger the query, but the model I will be querying might be already been changed by. So this is, careful to use. Although I forgot to mention this, I probably found a way out by just invalidating a cache, and then only the next time you really need access to this data, you do the request. So you somehow find a way around this many changes in a small period of time. But yeah, you're completely right. This is should definitely be on the challenges side of the slide. Yeah.
And there is an additional one. So what you can do is you can actually, I mean, we were experimenting with this around so that you kind of creating versions in your projections. And then you are able to communicate this version. So you can, so what we were actually using was like correlation, correlation provider between command, event, query. Or basically, no, command, event, this important one, then the projection gets some kind of a revision. Could be a timestamp, it could be just incrementing numbers. And then basically you can include this revision inside of your query, saying give me at least this version, or give me the version of that timestamp, or give me, so you can, this makes the projection a little bit more complicated, but sometimes you have exactly this business requirement because of some legal obligations, and they say like, what have you known at the 5th of January in that year, right? And then you exactly need this kind of history slice inside of your projection.
Yep.
Thank you so much, Simon and Jan. Thank you. Please help me thank them.
Thanks.